Y equals 1/4 x plus 7 squared. Sam.
Compressed vertically by a factor of 1/4.
Good. And?
And I don't remember.
Bridget, what does 7 do?
Move 7 units to the left.
Yep. What's the word for move?
Oh, it's translated.
Translated, you got it?
Sorry.
7 units to the left. Excellent. So those are the 2 things you'd write for the first one. Question B, John.
Why is
It's
it
vertically by a factor of 3 and reflected in the x-axis and translated 5 units down.
Good. So the negative sign is reflected in the x-axis. Separately, we deal with the negative and the 3. So that means reflected. The 3 is stretched vertically by a factor of 3. And the 5 is translated down 5 units.
Wait, it's stretched, but it's
Because it's a 3, right? It's not less than 1. So the negative sign is separate. It tells you that it's reflected, whereas the magnitude of it, the number of 3, just tells you that it's stretched. Yep.
So the stretch pattern multiplication thing is 1, 3, 5, 7.
Correct. So down here they're asking us to graph. In order to graph a parabola, the first thing we need to do is we need to plot the vertex, which you're going to take from the equation in vertex form. Then you're going to use the step pattern. It always goes over by 1, but it goes up or down by the steps. And you make the symmetrical points on the other side.
So wait, would the vertex be 1 and negative 3?
1, negative 3, absolutely. So you go over 1 and down 3, and you start there, and then you use the step pattern, the 1, 3, 5, to plot your points, but you're going to double it in the first example. So try question A.
Oh, so would we use like 2 for this next pattern?
You absolutely would, yeah, because the A
So
value
first
is
one
2.
would be 2 over 1. And then it'd be 5.
So start off at the vertex, which is the opposite of the number in the brackets. So positive 1, negative 3. That's the vertex. So it's going down here. Label it. And then for my step pattern, usually it's up 1, then up 3, then up 5. But now I'm going to double that. All of those steps are going to be doubled.
Now it'd be
So
5.
times 2, times 2, times 2.
Oh, times 2.
It's 2, 6.
So I go over 1 and I go up by 2 now. And that's the next dot right here. Then I go over 1 more and I go up by 6. Then over 1 more, up by 10, which goes way the heck off the graph. Okay. My points are going to be here, over 1 up 2, over 1 and over here, 6. The axis of symmetry is going to be drawn down the middle. Here's my axis of symmetry. Probably could be a little straighter. There we go. And I'm going to copy my points over to the other side. So that's one of the points, and that's the other one.
I thought it was always over. It's always over 1.
Always, always, always over 1. Yep. Absolutely. The axis of symmetry has an equation, right? It's x equals, and it's whatever the x coordinate of the vertex is. Thanks, Kelly.
Mine looks weird.
Looks weird as in just you're not used to drawing it, or is it not symmetrical? Check to make sure that you've gone over the proper number of boxes.
Well, no, I can't get that the last one.
Oh, wait.
Well, the top one doesn't fit, right? So we only do 2 steps. You don't need to fit the 5th one on there.
Okay.
The 5 steps. The next one would begin where? What's the vertex?
Negative 2,
Negative 2, 4.
Oh, it's been a while gone.
So over 2, up 4. Does it open up or down? Because it's got a negative sign in front of it. So from that point, I'm going to go down, and the A value is 1. So the steps are just going to be down 1, down 3, down 5. From here,
Shouldn't you write it out though?
pardon?
Shouldn't you plot it for it?
Over 1, down 1. Like this?
No, but shouldn't you write it out like negative 2 and 4? Like show what the vertex is?
I should, yeah, I should leave my vertex. Negative 2, comma 4. Thank you. And then over 1 and down 3. Over 1, down 5. Over 1, down 7. 7 would be off the graph, so I'm not going to worry.
No, 7 fits on the last line.
Of your graph?
Yeah.
Oh, my graph's different. That's okay. So axis of symmetry, down the middle. Its equation is x equals -2, and I'm copying my points to the other side. Questions about graphing? Or about transformations? Okay. So determining the equation. The steps for determining the equation are the same whether you're doing it in vertex form or in factored form. When I'm giving you the transformations, you're just plugging them in, right? If the vertex is -2, -1, that tells you your h and k. If it opens up, that tells you that the a value is positive. And the vertical compression factor, that's your a value. Right, I could ask you to find a vertical stretch or a vertical compression factor. So plugging those numbers in, y equals 1/3 is my a value. The h, which is -2, goes in the brackets, and the k goes outside the brackets. What am I going to write after the x?
+2
Yes, opposite signs.
and
X
then
plus 2
-1.
squared minus 1. Don't forget your squared sign. If it's not squared, it's a line.
Wait, in factored form, they're not squared.
No, because there's 2 of them, right? 2 x's makes the x squared. Good question. So question B asks you to calculate the equation or work it out algebraically if the vertex is 1, 5 and it passes through another point. Right? I can ask you to do this with vertex form or with factored form. And the steps are going to be exactly the same. If you want to, you can write the steps on the next page where it says steps in question number 7. Number 7 and number 5 are the same process. Exactly the same process, just they're different forms of the equation. If I were going to redo this, I would put them next to each other. Okay. So if you want, you can put a little note to yourself. This is like number 7, except number 7 is factored form, whereas number 5 is in vertex form. I'm going to drop them down. Oops. I drop them down right here on number 7, just because there's space for them. But we're going to do them in both questions. I'm going to write number 5 right next to it. Whenever you want to find an equation, write it out in the general form. So if it's vertex form, write it the vertex form. If it's factored form, write it out in factored form.
I think it's going to be factored form.
Number 7 is, but number 5 is vertex form. They're different,
Alright.
right? So 7, what's special? I wrote what's special because that will work for both forms, right? If it's vertex form, the vertex is what's special. If it's factored form, what's special for factored form? The roots, exactly. So no matter what I ask you for, if you plug in the special feature first, the other information you're given is your x and your y. So you don't really need to remember anything for this process. It's always the same thing. Plug in what's special, whatever's left over is my x and y. And I'm solving for the a value, because if I ask you for the equation, I haven't told you if it's stretched or compressed vertically. So I'm going to do number 5 with you, and then you're going to try number 7 on your own. I'll put these steps over here in case anybody's still copying so that they don't feel like I just moved the page on you.
Wait, Miss, as for 5B, do you have to like
Do this stuff, right?
do you have to find the slope of the two?
Well, there's no slope for a parabola, right? But we're going to do these 5 steps right here. Let's write out the equation. Now, because we have vertex, we're going to use vertex form. Y equals a bracket x minus h squared plus k. That's the first step. Write out the equation. Then I'm going to sub in what's special. What's special to this form? The vertex, right? The h and the k. So 1 is the h, 5 is the k. I'm going to plug those numbers in right here. So h is +1. I'm going to go -1 in the brackets and +5 at the end. Those are the coordinates of the special feature of that equation. then the leftover point, which in this case is the 0, 2, that's going to become the x and the y. So this is my x and this is my y. So if it's y equals, the 2 replaces the y. So 2 equals, and wherever I see an x, I'm going to put the 0. So my equation is going to end up looking like this. 2 equals a times 0 minus 1 squared plus 5. I only have one letter left over, and it's the a value. And that's what I'm
Solve
going
for
to
a.
solve for, exactly. Right? Because you need an a value in your equation, right?
I guess you do.
So, follow bedmath. 0 minus 1 is negative 1
Negative.
squared. You don't need to write out as many steps as I'm going to write out. I want to
Just
make
one.
sure that you're okay. Okay, so negative 1 times itself is just a 1. Whatever this answer is, just scooch it over in front of the a value. You don't usually say like a4, you say 4a, right? So you're going to get an answer here. It's not always going to be a 1, but that number is going to go in front of the a.
So you're gonna have an a plus 5.
And the left side is 2. Now if I want to solve for a, I don't want the 5 there. The 5's out of
So
place.
get the 5.
We're going to move it over to the left-hand side. Make sure to do the opposite. 2 minus the 5 equals a, so a equals negative 3.
So then we write the equation
You have to put the equation in at the end, exactly. So y equals
negative 3 x.
negative 3 bracket x, and then something squared and something else at the end. When you write an equation, the x's and y's stay as letters. You do plug in your vertex though, negative 1 and plus 5. That's the final equation. Now I want you guys to do number 7. It's the exact same thing except for it's a different form. It's factored form. For the r and the s are your roots.
Shouldn't we do 6 first?
No,
Okay.
no, we're going to skip 7. We're going to go back to 6 in a minute. So do question number 7. It's exactly this, but different form of the equation.